Last episode, we learned about the Bernoulli distribution. One experiment, two possible outcomes, success or failure. But what happens when you repeat that experiment again and again and again? Flip one coin and the question is easy. Will it land on heads? But flip 10 coins and the question changes. How many heads will you get? That's where the binomial distribution begins. A Bernoulli distribution asks, what happened in one experiment? A binomial distribution asks, what happened after many Bernoulli experiments? Notice something. We're no longer interested in the exact sequence. We're interested in how many successes occurred. Flip 5 coins, heads, tails, heads, heads, tails, 3 successes. Binomial distributions appear everywhere. How many free throws does a player make out of 5? How many of 10 emails are spam? How many patients test positive? How many images did the AI classify correctly? Notice the pattern. We're always counting how many successes out of a fixed number of trials. Not every repeated experiment is binomial. 4 conditions must be true. First, the number of trials must already be decided. 5 flips, 10 flips, not keep flipping until something happens. Second, each trial must have only 2 possible outcomes, success or failure. Third, every trial must have the same probability of success. And finally, each trial must be independent. One flip shouldn't influence another. Suppose we flip 5 fair coins. What values can the number of heads take? 0, 1, 2, 3, 4, or 5? Notice, we're not recording the order, only how many heads occurred. These become the outcomes of our binomial distribution. Next, we'll figure out which of these outcomes is the most likely. Here's something surprising. Unlike the uniform distribution, these outcomes are not equally likely. Getting 2 or 3 heads is much more common than getting 0 heads or 5 heads. Why? Here's a question. How many different ways can you get exactly 3 heads? Wait, there's more than one way. Exactly. When we say exactly 3 heads, we don't mean one arrangement. We mean every arrangement that contains exactly 3 heads. Each one of these gives us 3 heads, and each one contributes to the final probability. The more possible arrangements, the higher the probability. That's why outcomes near the middle happen much more often. Think about it. How many ways are there to get 0 heads? Only 1, tails, 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 tails. 5 heads, also only 1, but 3 heads, there are many different arrangements. More arrangements means higher probability. That's why binomial distributions usually peak somewhere in the middle. This formula scares a lot of students, but let's read it like a sentence, not memorize it. N is the number of trials. X is the number of successes. P is the probability of success. And 1 minus P is the probability of failure. Every symbol simply represents something we already understand. The formula just puts them together. Let's solve one together. We flip a fair coin 3 times. What's the probability of getting exactly 2 heads? There are 3 different arrangements. Heads, heads, tails, heads, tails, heads, tails, heads, heads. Each arrangement has probability 1/8, and there are 3 such arrangements. So 3 times 1/8 equals 3/8. Why should an AI engineer care? Imagine your spam filter processes 100 emails. The binomial distribution helps answer questions like, how likely is it that exactly 95 emails are classified correctly? It also appears in A/B testing, quality control, medical trials, and model evaluation. Whenever you're counting successes across repeated independent experiments, you're using binomial thinking. Let's summarize. A binomial distribution is built from repeated Bernoulli trials. We're counting the number of successes. There must be a fixed number of trials. Each trial is independent, and the probability of success stays the same every time. 5 fair coins are flipped. What values can the number of heads take? 0 through 5. True or false? A binomial distribution requires every trial to have the same probability of success. True. A basketball player takes 10 free throws, and we're interested in how many shots they make. Which distribution should we use? The binomial distribution. Remember it like this. Bernoulli is 1 trial, repeat it. Count the successes, that's binomial. Something incredible happens when the number of trials becomes very large. The binomial distribution slowly transforms into one of the most important distributions in all of mathematics, the normal distribution. We'll discover why that happens in the next few episodes.